The dielectric and conductor losses are also there after radiation losses. So conductor losses, mainly we all know that in case of microstrip patch antenna, if I'll say, the radiation will take place because of the fringing fields. Okay, now fringing fields is coming, and suppose the conductor is infinitely long, then there will be no losses at all. Fine. Okay, smooth surface cannot be achieved, therefore losses will be more. Some irregularities will be there in the surfaces. Okay, so that's why some will distort, some will lose, some will destroy only some waves. That time also this kind of conduct losses will be there, due to which we all know that perfect electric conductor will not be there. That's why this losses will occur. Regarding the dielectric constant, we have a role only for a substrate having high loss tangent will contribute more dielectric losses, just like FR4. As you can see in this, the dielectric constant is, we all know, 4.3, and in cases of dialect loss tangent it is 0.02, whereas in case of 5880, that is Roger altitude, right, it is having a loss tangent as 0.0009. So much of difference is there, so that kind of dielectric constant will be there, by which some dielectric losses will be there. Higher the value of dielectric constant, more will be the lossy, and please check with the loss tangent even. Okay. Before that, before going to types of feeds, I would like to tell about the surface wave loss. Now, surface wave losses, generally it will happen in a array, if I'll say. Why? Because suppose the waves are traveling. Now one layer is conductive, then another is dielectric, then again it is conductive layer. So travel wave will travel in between some different medium continuously. Okay. After that, since in array, suppose four element array or 8 element array, we are having number of elements. So each waves which will travel, it will continue to travel to other elements as well, by which, because of which mutual coupling will increase and radiation pattern will get deteriorated. So that's why this kind of surface wave loss will also used to be minimized, and that too in case of array antenna it has to be minimum of half wavelength from that, and that too a center to center spacing. Okay, now I'll start with the types of feeds. As I've already discussed, that to excite the antenna, feeds are incorporated. Therefore, it is said that designing a feed network is important to obtain the right performance of the desired antenna at the desired frequency. Okay, so these feeds are also divided into two broad categories, which are contacting and non-contacting methods. As you might guess from the by name itself, that contacting means which are directly connected to your radiator. Radiator is your what? Patch. And in case of non-contacting means which the feeds, antenna feeds which are not directly connected to the radiator. Okay, so in this contacting methods, two are there, which are microstrip feed line and coaxial probe. Okay, and further in non-contacting method, proximity coupled and aperture coupled is there. Okay, we'll start with the microstrip line feed. As you can see in this figure,